sensory, you're ascending. For motor, you're descending. I want to touch the tip of my finger to the tip of my nose. I gotta control motor neurons in my spinal cord to do that. Motor association cortex, area 6, or premotor gyrus or premotor strip, relays to area 4, and then area 4 is going to relay out. Come from area 4 to mes, on, med, sc, all the way down the brainstem. Motor make up descending fibers. They come out of the cerebral cortex and go down the brainstem, headed to the spinal cord. And again, we'll be spending hours on the motor system next semester, but in a nutshell, for voluntary motor behavior, 6 is going to talk to 4, and 4 is going to relay out the motor neurons in the spinal cord. We'll talk about that in a minute. 6, 4, and down. 4 is primary motor cortex, 6 is association. It's opposite sensory. Sensory processes going up, primary, secondary, and association. Motor comes out. Association, primary, and down. Now, this is the cross-section for the mesencephalon. Cross-section through the mesencephalon. Now, I want you to notice the bumps on the top. Bumps on the top are called the colliculi. And if you look at this picture over here, you notice this is a longitudinal section, this is a cross-section. Notice as I look at it this way, there's a colliculus there, actually a pair of them, and another pair over there. The colliculi are named by their relationship to each other. So these are the superior colliculi and inferior colliculi. Now, I know this is going to come as a shock, but the superior colliculi are superior to the inferior colliculi, and the inferior colliculi are inferior to the superior. That's something. Now, what do they do? Okay, the colliculi are important for sort of reflex orientation. Let me describe. over there. I turn to see what it is. Visual is superior. Auditory is inferior. Okay? These are reflexes. Okay? It's not this. Suddenly there's a flash of light off to my right. Oh, there is a flash of light off to my right. I think I'm going to turn and look and see what the fuck it is. No. Right? These are visual and auditory reflexes mediated by the colliculi. The colliculi give rise to two very important tracts. I'll start with tectospinal. When you do central nervous system and we talk about tracts, most of them are named by where they come from and where they go to. The colliculi are often called the tectum. Tectum means roof. And indeed, the tectum make up the roof of the mesencephalon. So tectospinal are fibers that arise in the colliculi and descend to the spinal cord. Okay? They descend to the spinal cord. So, for example, if an object is moving towards you, you might move your body toward that object as it's coming toward you. The other thing is, not only will your body move toward a target, but your eyes will move to a target. Eye movements seem very simplistic, but they're very complicated. If I, for example, look to the right, all right? My eyes look to the right. I don't know if you've done cranial nerves yet, and we'll mention them in a little bit of them. But if I look to the right, my right eye moves this way, and my left eye moves that way. My right eye moves away from my nose, and my left eye moves toward my nose, right? What's this movement called? Do you know yet? Abduction, right? What's this movement? Adduction. What cranial nerve is this? This. 6. Abducens and lateral rectus. This is 3 and medial rectus. So a simple thing like looking to my right or looking to my left is very complicated. I've got to tie together the function of 2 different cranial nerves and 2 different muscles on either side of the body. And what does that is a tract that comes from the colliculi that is called the medial, longitudinal, fasciculus. Now, I can't waste my time saying that all the time, and no one ever says medial longitudinal fasciculus. They say MLF. And what does the MLF do? Ties together cranial nerves and eye muscles so they work together. Okay? Now, last time I checked, step one. It's an extremely important track, as you will see next semester. About 5 to 7 questions on MLF in step one, and about 4 questions in all of gross anatomy. Okay. We're going to spend a while talking about MLF, about 1 lecture and a bit. Next semester, all you need to know for now is it is an important tract that comes from the tectum or colliculi that tie together the function of eye muscle. It works with the tectospinal tract. Okay? So, I'm going to show you why in a minute. These are the superior colliculi. These owl eyes over there are called the red nuclei. I don't know what people were drinking when they said they were red. They're not. They're kind of grayish. We'll be dissecting human brains next semester, and you'll see them. Red nuclei are important structures for the motor system. The superior colliculi are found at the level of the red nucleus. So if you see bumps on the top here, and you don't see the red nucleus, guess what they are? The inferior colliculi. So if I showed you this picture just like that, with nothing labeled, and I say, what are those? You'd say superior colliculi. Or they give rise to the MLF. All right, now, right here, this little black mustache, and it is indeed a black mustache, is called the black substance. The substantia nigra, the black substance. And it is black, dark, dark, dark. For reasons we'll tell you in a second. Everybody knows what's substantia nigra important for. What happens if I destroy the substantia nigra? Patient has Parkinson's disease. We'll spend a lot of time talking about Parkinson's. They develop Parkinson's disease because of a depletion of a certain neurotransmitter from the substantia nigra. Anybody know what that neurotransmitter is? Dopamine. The byproduct of the manufacture of dopamine is melanin. And so you have deposits of melanin, and it is black. Over here, you have the crus cerebri or cerebral peduncle, one on either side. These contain descending motor fibers. I'll wire them up for you in a bit. This is the cerebral apparetus. system of the brain. The immediate importance of the ventricular system of the brain is that the ventricular system, which is a whole, contains CSF, cerebrospinal fluid. And next semester we'll talk in great detail about the function of cerebrospinal fluid. But I'm just looking over here. In the mesencephalon, there is a hole containing CSF, part of the ventricular system of the brain. This part is called the cerebral aqueduct. Not the aqueduct racetrack that's in Queens. Now, around the cerebral aqueduct is an area of gray matter. We define gray matter. What is gray matter? Dendrites and so on. And then the neurons, the axons, make up white matter. So there's gray matter around the cerebral aqueduct called periaqueductal gray. And periaqueductal gray is extremely important because that is the major center in the brain where analgesics work. After my knee surgery, I can't get out of bed unless I take 10 milligrams of oxycodone. That's where the oxycodone works.
That's good stuff.
Block pain. Okay. All right. That's a very important cross-section. I love that cross-section. There could be questions with pictures on the exam. The national boards love this cross-section. All right? You will see it on step 1.
And blocker.
And you will see it 40 times more in Med 2. This is an introduction to the brain stem, mesencephalon. Other things in there we'll talk about next semester. Mesencephalon, pons. I say pons, you say metencephalon. Rhombencephalon, right? Metencephalon gives rise to pons and cerebellum. Cerebellum sits up there. It ain't part of the brain stem. Now, there's not too much we need to talk about in the pons right now, other than it's part of the brain stem. Let's talk about the medulla. If we look at the medulla, all right, it kind of looks like this a bit. There's the midline. Egypt because there'd be 3 pyramids. I'm in the middle. Now, in a little bit, I'll tell you about what the pyramid is, but for now, I'm going to leave the olive as a cerebellar relay nucleus. Relays important information to the cerebellum. And really, the olive bulges out because deep inside is a huge nucleus. And the nucleus is the relay nucleus, the inferior olivary nucleus. You can use them kind of interchangeably, olive or inferior olivary nucleus, but recognize it as a major cerebellar relay. Now, let's figure out what the pyramid does. Okay, let's figure out what the pyramid does. I want to touch the tip of my finger to the tip of my nose. We said there is a motor homunculus in area 4, did we not? There are actually 2 homunculi in area 6. Doesn't matter. They project in topological order onto the homunculus in area 4. So, head regions to head region, right? Head regions to head region, hand to hand, foot to foot, etc., etc. They project in topological order onto area 4. Voluntary motor behavior is initiated in area 6, motor association cortex. 6 projects in topological order to 4, and 4 gives rise to the corticospinal tract, down to what are called lower motor neurons, which project the skeletal muscle. So I want to touch the tip of my finger to the tip of my nose. It actually begins as a thought, but that's not complicated. Anybody here define me what a thought is?
Thought? Thought.
When you can, tell me, you'll win the Nobel Prize. Begins as a thought in the prefrontal lobe. That's related to 6, and voluntary motor behavior is initiated as per your thought. Relate to 4, and 4 down to lower motor neurons, and you move your muscle. Lower motor neuron, muscle. And again, we're going to spend hours, weeks talking about these circuits. Now, how does the information go from 4 down on the corticospinal tract? There is no microwave transmission into the spinal cord. Now, let's look at mesencephalon. Where are they found in mesencephalon? Right here. Right there. Right there. I find corticospinal fibers in the cruce, in the cerebral pedone. Is on medulla. There's no sexy place in the pons. They just run in the midline base of the pons. It's called basis pontis. And what's midline medulla? Pyramid. They're running right in the pyramid. That's why the corticospinal tract is usually called the pyramidal tract. It runs in the pyramid of the medulla. Can't find them in Egypt. It's the pyramid of the medulla. Now, a few minutes ago, I showed you the olive over here, right? And I said there's a cranial nerve that runs between the pyramid and the olive. What one was it? What I told you, but if not, probably not. Well, what's the 12th cranial nerve do? You know? 12th cranial nerve does this. Most important nerve in the body does this.
Hypoglossal.
That's the most important nerve in the body.
Hypoglossal.
Why? It didn't have it popped up. What did it? All right. So, I told you that it's important to know that the corticospinal tract runs in the midline of the brainstem, right?
We're going to turn
At
on.
the level of the medulla, it's right at 12. Right?
So that was erotic.
What's cranial nerve is found midline 6? Do you have any? I'm sorry, I told you. Midline pons. 6. So, let's talk about clinical importance. Remember, you're looking at your patient's brainstem. So your right is his left, and your left is his right. All right. Now, let's say I had a problem. I had a CVA, cerebrovascular accident, and as a result, the corticospinal tract is knocked out in the brainstem. That would have to be blood supply to somewhere in the midline of the brainstem, right? That's where the corticospinal tract relays. Right? Everybody agree with me? Now, if it was midline medulla on the right, your patient would be paralyzed on their left side. Right? Say, hey, pick up your left arm. They'd be paralyzed on their left side. But if you told them to stick out their tongue, it would deviate to the left. the tongue would be paralyzed on the right. Okay? That tells you that the problem is in the medulla. On the midline of the medulla. You've knocked out the corticospinal tract, and you've knocked out cranial nerve as well. What if it was pons? What if I had a blood supply problem to midline pons? On the right. The patient would be paralyzed on the left, wouldn't it? And how would you know it was pons? Because you knock out cranial nerve 6. And what does cranial nerve 6 do? Ipsilateral abduction. What the fuck does that mean? Ask your patient to look to the left. Sorry, right, on the right side. Left side paralysis and 6 on the right. Ask your patient to look to the right. Start a target over here and move it to the right. What will the eyes do? The eyes will do this. That eye cannot abduct. Again, follow a target. Knock out cranial nerve 6 on the right. That eye can't go beyond primary gaze position. Straight ahead. See that? You can't abduct on the right. Follow the target. Moving to the right. Left eye abducts, right eye cannot abduct. So, I lose ipsilateral abduction. All right. Let's kick it on up a notch. Everyone's coming through, of course. We're going to kick it on up a notch. What if we had a CVA involving midline mesencephalon? What cranial nerve comes out of it? Three. Ipsilateral adduction. Right? That's adduction. Look away from the nose. All right. What would happen if I had a midline CVA on the right side of the mesencephalon? I'm going to knock out the corticospinal tract, right? So the patient's going to be paralyzed on the left. Patient's going to be paralyzed on the left. We just find the board next to that. And we knock out 3 on the right. And what does 3 do? Adduct. Okay? So now, follow a target to the left. Ready? Follow the target to the left. Right eye cannot abduct. So, this is extremely important for you as clinicians. How do I localize a CVA in midline brainstem? I look for the affected cranial nerve. Again, this is very easy stuff. Look at it.